Good evening, my dear students. Welcome to my channel Biochemics with Ajay MNR. Today, I have come up with an exciting topic, which is light. In that, we are going to discuss refraction of light. So, all of you watch this video and learn the concepts. If you have any queries, and you please message to me, and you can give comment also. After watching this, please like it, share it, and subscribe it. Thank you. All the best. Okay, students, without further delay, we will get into our question and answers discussion. Our topic is light, refraction of light. In this, we are going to discuss question and answers, textual questions and answers, and even in-text questions also. Here is your first question. A ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? Why? Here first we'll see what is a normal. Normal is nothing but a ray which is drawn perpendicular to the principal axis or surface of. Okay, here light is moving from air to water. That means air and water, these two are different media. Air is rarer media and water is denser media. When light moves from rarer medium to denser medium, it deviates it from its path. Okay, when it moves from one medium to another medium, depends upon their densities, it either move towards normal or go away from the normal. Now you'll see the answer. The light ray bends towards the normal in this case. Why? See, when a light ray enters from an optically rarer medium, this rarer medium has low refractive index to an optically denser medium which has high refractive index. That means light is coming from the medium which has a low refractive index to the medium which has high refractive index. Its speed slows down and bends towards the normal. So when light moves from rarer medium to denser medium or air to water, when it enters into water, its speed of the light slows down. As a result, it bends towards the normal. As water is optically denser than air, a ray of light entering from air into water will bend towards the normal. If if at all light moves from water to air, it will be opposite. That means the light ray, refracted ray, will go away from the normal. This about this question. Now we'll see the next question. Light enters from air to glass having a refractive index 1.5. What is the speed of light in the glass? The speed of light in vacuum is 3 times 10 power 8 meters per second. So here in this question, we have seen two media. One is air, second one is glass. And here refractive index are already given. That means refractive index of glass with respect to refractive index of air. Now, what is the speed of light in the glass? Actually, what is the speed of light in vacuum is already given. It's 3 times 10 power 8 meters per second. Now, from this data, we have to find out speed of light in the glass. So definitely glass is a denser medium. The speed of light will be lesser than the speed of light in vacuum, definitely. Let's see what's the speed of light in the glass. Refractive index of a medium that equal to speed of light in vacuum upon speed of light in the medium. In the medium means the given medium. Here the given medium is the glass. That means we are comparing speed of light in the glass to the speed of light in vacuum. This is the refractive index of a medium. Now, speed of light in vacuum, that is C, is equal to 3 into 10 power 8 meters per second. It's in vacuum. Generally in air also we consider the same value. A refractive index of glass is given, that is Ng. N refers refractive index, G refers glass. So refractive index of glass is already given, that is 1.50. That means the refractive index, the bending of light in glass when compared to air, will be 1.5 times more. 1.5 times more. Now speed of the light in the glass, V, speed of the light in the glass, V. In vacuum we denote by C. In the glass we denote the speed by V. That is equal to speed of the light in vacuum upon refractive index. Refractive index. Now speed of light in vacuum, that is C, upon refractive index of glass, that is Ng, that is equal to 3 into 10 power 8. This is speed of light in vacuum upon refractive index of glass is 1.50. That gives you 2 times 10 power 8 meters per second. Now we calculated speed of light in the glass, that is 2 into 10 power 8 meters per second. Here in this problem we are given refractive index of glass and speed of light in vacuum. Now speed of light in the glass, that's what we have calculated here. Next question. From the table, I think a table is given in the textbook. From the table, the medium having the highest optical density. We have to find out that one, and also find the medium with the lowest optical density. See here, if the optical density is more, speed of light will be lesser, slower. If the optical density is less, speed of the light will be higher, opposite. Now we'll see answer. Lowest optical density is air. From the table is not given here. Highest optical density is diamond. It is there in the textbook. The optical density of a medium is directly related to its refractive index. That means if optical density is more, bending of light is also more. That means refractive index is also more. If the optical density is less, and then speed of the light, bending of light with a small angle, that is also less, and refractive index also less. But if optical density is more, speed of light will be less. If optical density is less, speed of light will be more. So optical density, refractive index are directly proportional to each other. Optical density and speed of light are indirectly proportional, inversely proportional to each other. A medium with the highest refractive index will have the highest optical density and vice versa. It can be observed from the table that air and diamond respectively have the lowest and highest refractive index. Now we'll see the next question. One more point. Hence, air has the lowest optical density and diamond has the highest optical density. Air is about 1.0003 something, and diamond is more than 2.5, like that. Now let's see the next question. You are given kerosene, turpentine and water. Three liquids are given here. In which of these does not light travel fastest? Fastest. Does the light travel fastest? Use the information given in the table. Again, you have to refer the table. which is given in a textbook. Okay, so kerosene refractive index is given, turpentine refractive index is given, as well as water refractive index is also given. Though these three are liquids, their densities are different. The one which is high denser, in that refractive index will be high, but speed of light will be slower. Okay, now we'll see the answer. Light travels faster in water as compared to kerosene and turpentine. That means light water is less denser than kerosene as well as turpentine. Turpentine is among these three. Turpentine is the high denser liquid. Kerosene is the medium. As the refractive index of water is lower than that of kerosene and turpentine, so the speed of light is inversely proportional to the refractive index. So water's refractive index is less, speed is more. Turpentine refractive index is more, speed is less. Now we'll move to next question. The refractive index of diamond is 2.42. What is the meaning of this statement? So the highest refractive index, this is here, in which speed of light is very slow, and moreover light bend towards normal. Let's see answer. A diamond has a refractive index of 2.42, which means that the speed of light in a diamond will reduce by a factor of 2.42 as compared to its speed in the air. That means, see, here we have to compare speed of light in air, that we have to take as a reference to compare with any other substance, any other media. Here, the speed of light in diamond will reduce by a factor of 2.42 as compared to its speed in the air. For example, speed of light in air is 4.84 refractive index. Speed 4.84 for example. But here it's around 2.42, almost, right? Half. By the same factor, the speed of light will be reduced. Next question. And in other words, the speed of light in a diamond is 1 by 2.42 times the speed of light in a vacuum. That means very small. 1 by 2.5 means it's almost how much? 4 times lesser than air. The speed of light in diamond is 4 times lesser than air. Okay. Now, next question. Define one diopter of power of a lens. See, my dear students, we already discussed that power of a lens is measured in terms of diopters. Now, how can you define one diopter here? Diopter is the SI unit of power of lens, which is denoted by the letter capital D. One diopter can be defined as the power of a lens of focal length 1 meter. For example, if you have a lens, its focal length is 1 meter, then its power is 1 diopter. If focal length increases, power decreases. If focal length decreases, power increases. So focal length is inversely proportional to power. Now next question. Find the power of a concave lens. Concave lens of focal length 2 meters. Concave lens, this is a diverging lens. Concave lens is a diverging lens and its focal length is 2 meters. And you are asked to find out power. So power formula, we know that power equal to 1 by focal length. Now we'll see. The focal length of the concave lens f equal to 2 meters. It is given already. Now power of a lens equal to power is equal to 1 by f, that equal to 1 by minus 2 that equal to minus 0.5 d. Here it is given minus 2 because concave lens which forms image on left hand side on the same side of object. So left side of the lens, that is always negative, right? So 0.5 diopters. Next question. A convex lens, remember convex lens is a converged lens, forms a real and inverted image of a needle at a distance of 50 centimeters from it. Where is the needle placed in front of the convex lens if the image is equal to the size of the object? And also find the power of the lens. See, my dear students, first read the question. In this, you just find out what are the key points given here. One is convex lens is given. It's a almost it forms real and inverted. That's we know that one. And second thing is you see here equal to the size of object. Image is equal to the size of the object. When does an image is equal to the size of object? When object is at the center of the curvature in case of a mirrors, or when object is at 2f1 in case of convex lenses, the image will be same size. Image will be same size, and find the power of the lens. This is our question, in which needle is an object. Actually needle is an object and which is 50 centimeter away from the lens, from convex lens. Now we have to find out distance, needle distance. Where is the needle placed in front of the convex lens if the image is equal? Okay, now we'll see. The position of the image should be 2f, since the image is real and the same size. 2f on the left hand side, the position of image right hand side, it should be uh, at 2f, because since it is same size. It is given that the image of the needle is formed at a distance of 50 centimeter from the convex lens. So image object is at 50 centimeters on left hand side, and image is also at 50 centimeter on right hand side. Therefore the needle is placed in front of the lens at a distance of 50 centimeter. Okay, now object distance we will see, that is minus 50 centimeter. Object is always on left hand side, it is to be taken as minus, negative value. Image distance v is equal to 50 centimeter, since it is on the right hand side of a lens, it is taken as positive value. Focal length is f. Focal length is not given here. According to this lens formula, we have to use formula here. Now 1 by v minus 1 by u is equal to 1 by f. So 1 by f is equal to 1 by 50 minus 1 by minus 50. Minus 1, that means 1 by v minus 1 by u. Now 1 by 50 minus plus 1 by 50 is equal to, just do some LCM here, you will get 1 by 25. This is 1 by f. 1 by f equal to 1 by 25. Now f focal length equal to 25 centimeters. Since this focal length always power will be given in terms of meters. We have to convert the centimeters into meters. So 25 centimeters is equal to 0.25 meter. Now we got a focal length here. Now we have to find out the power. So power of lens is P equal to 1 by F, that equal to 1 by 0.25, that equal to plus 4D, plus 4D, plus 4D. Here plus positive symbol that indicates convex lens. Convex lens. Negative symbol indicates concave lens. Remember this, very important. In the power, if a positive symbol is given, that the lens which is used there is convex lens. If a negative sign is given, that lens is concave lens. So this is about this question. Now next question. The image formed by a concave lens is observed to be virtual, erect, and larger than the object. We know that concave lens, it forms a virtual and erect image will be formed on the same side of the object. Where should be the position of the object? Where should be the position of the object? See, my dear friends, if an object is at infinity, we know that image is formed at principal focus. If object is bringing towards a lens, then automatically the distance of image move away from the lens. Now we'll see the answer. Options are here. Between the object should be between the principal focus and the center of the curvature, at the center of the curvature, beyond the center of the curvature, anywhere between the optical center of the lens and its center of the curvature. It is 2f1. 2f1. Now let's see the answer. It is anywhere between the optical center of the lens and its center of the curvature, 2f1. This is your answer. Now, where should an object be placed in front of a concave lens to get a real image of the size of the object? Real image, we should get real image, size of the image of size of the object. That means same size of the object. Option A, at the principal focus of the lens, at twice the focal length, at infinity, and between the optical center of the lens and the principal focus. What's your answer? Now, the correct answer is the object should be placed at the twice the focal length. That means it should be at center of the curvature. Here we have to say that is at 2f1. 2f1 in terms of lens. Now we'll see the next question. Which of the following lenses would you prefer to use while reading small letters found in a dictionary? So generally we see this problem many people are facing, and particularly at old people generally, and they find difficulty to read letters from diaries and all, or dictionary. It is now become common in even young people also. Now we'll see the answer. Option A convex lens of focal length 50 centimeter, a concave lens of focal length 50 centimeter, a convex lens of focal length 5 centimeters, a concave lens of focal length 5 centimeter. So they are finding very difficult to read dictionary. Now tell me what kind of disease it is, myopia or hypermetropia? If you found this hypermetropia, that means they can see longer objects, they cannot see nearer objects. Okay, we'll see what is it. Your answer is a convex lens of a focal length 5 centimeter can be used while reading small letters found in a dictionary. Convex lens we have to use. Generally, people are suffering from myopia. That means they can see things from close, they can't see things from distance. So generally, most of the people they suffer from myopia, but few people, less people, they suffer from hypometropia. That is um, long-sightedness. They can see long things easily, but shorter one very difficult. For them, a lens suggested is convex lens. Convex lens is suggested for them for hypermetropia. Next question. One half of a convex lens is covered with a black paper. Will this lens produce a complete image of the object? Verify your answer experimentally. Explain your observations. Your answer. Yes, it's already, this is an activity given in the textbook. All of you please refer the textbook and find out the solution from there. Try to understand that activity. Now the answer is yes, it will produce a complete image of the object as shown in the figure. The figure also there in textbook. Please refer it. While preparing these question and answers, keep your textbooks close to you. This can be verified experimentally by observing the image of a distance object, like a tree on a screen, when the lower half of the lens is covered with a black paper. So the half which is not covered with black paper, that forms an image. Simple. Hence, the intensity or brightness of the image will reduce. Next question. An object 5 centimeter in length is held 25 centimeter away from a converging lens of focal length 10 centimeters. Draw the ray diagram and find the position, size, and nature of the image formed. See, my dear students, first look at any clue point is given here. It's a converging lens. Converging lens means convex lens. Convex lens. Convex lens generally forms real and inverted images. Right? Now, here object size is given. That length is nothing but size. It is 5 centimeters. Object size always it's above the principal axis. Since it is above principal axis, it should be positive, and it is left side to the and it is left side. If image is formed above principal axis, that is positive. But object is left side to the lens, that is taken as negative, and it is away from the lens 25 centimeters. So negative should be taken. Object height above this one. So it's a now the focal length is given 10 centimeters. Now we have to find out position, size, nature of the image, and finally we have to draw a ray diagram. Now we'll see the answer. Height of the object is given as 5 centimeters. It's a positive. Distance of the object from the converging lens u, that is minus negative 25 centimeters. Focal length of a converging lens, that equal to 10 centimeter, because lens focal length will be on right hand side, that is positive. Using the lens formula, right, we have given data here. Object distance is given, and focal length is given, object height is given. So we have to find out image distance and image size, nature of the image. Now you see a formula here. 1 by v minus 1 by u is equal to 1 by f. So we need 1 by v. Now 1 by f plus, bring this 1 by u to the right side, that is 1 by u, that equal to 1 by 10 minus 1 by 25. It comes around 15 by 250. This is 1 by v. Now we need v, image distance we need, that is reciprocal 250 by 15. It comes around 16.66 centimeters. So now you see object distance is 25 centimeter, image distance is 16 centimeters. Now tell me, here focal length is given 10 centimeter. What is the center of the curvature here? It's 20 centimeters. 20 centimeters, right? Exactly. But here image is in between 10 and 20. That means image is formed between optical center. Image is formed between focus and center of the curvature. Also, for a converging lens, height of image is equal to height of object, that equal to v by u. Now we have to find out height of image because height of object is already given, that equal to v by u times height of object. So if you substitute all these values here, 50 into 5 upon 3 into minus 25, you will get 10 by minus 3, and finally you get 3.3 centimeters, minus 3.3 centimeter. Height of image is minus 3.3 centimeter. Since it is real and inverted, image will be formed below principal axis. So we got height of image also here. Now we'll draw a ray diagram. So this is a ray diagram. You see here, object is behind center of the curvature, beyond center of the curvature, that is 2f1. When object is beyond center of the curvature, image will be formed between focus and center of the curvature. That means here focus is f2, center of the curvature is 2f2. It's 3.3 centimeters away from the lens. So here, since height of object is smaller, height of image is smaller, it is diminished image. Nature of image is real inverted. Size of image is 3.3 centimeters. And position of image is between focus and center of the curvature. Now we'll see the next question. A concave lens of focal length 15 centimeter forms an image 10 centimeters from the lens. Focal length is given, similar same time image distance also given, that is 10 centimeter. How far is the object placed from the lens? See here, focal length is given 15 centimeter. Image is formed 10 centimeter away from the lens. It's a concave lens. So to get your image 10 centimeter away from the lens, where should you keep your object? That is the question. After that, we have to draw the free diagram. Now let's see answer. Focal length of a concave lens, that equal to minus 15 centimeter. For concave lens, focal length will be on left hand side. For convex lens, it is on right hand side. Image distance V is equal to minus 10 centimeter, since image is also formed on left hand side, same side. According to the lens formula, now let us substitute all these values in this formula. 1 by V minus 1 by U is equal to 1 by F. This is the formula. Now we need 1 by U. That means object distance we need. So if you shuffle this 1 by V minus, just bring this 1 by F in place of 1 by U. So 1 by V minus 1 by F, that equal to Here V is negative 10 centimeter, so 1 by minus 1 by 10 minus, and focal length also negative 1 by minus 15. So minus 1 by 10 plus minus minus plus 1 by 15. Now LCM, you have to keep LCM. If you calculate LCM here, you will get 150 by 5 minus 150 by 5. Now we need V, we need U, that is 5 by 150 is equal to this this 1 by V, actual 1 by equal to minus 5 by 150, that equal to V equal to minus 30 centimeter. Image distance, object distance is minus 30 centimeter, because image distance already given 10 centimeter. Object distance, that is U, that is minus 30 centimeter. It's actually printed wrongly. It is U, actually it's U. So the distance of object is three times more than the distance of image. That means object should be beyond C. Now we'll see the ray diagram. Now you see here object is at almost it's at focal length, center of the curvature. Now if you see diagram here, image is formed between optical center and focal length. It's 10 centimeters away from focal length. From lens, focal length is 15 centimeter, center of the curvature, and object is at 30 centimeter. That means object is exactly at center of the curvature. Now image is formed. So wherever you keep object, image is formed between F and 2F, F and optical center. The negative value of U indicates that the object is placed 30 centimeter in front of the lens. This is shown in the following ray diagram. So while substituting values in the formula, you have to take care of minus plus symbols, otherwise you will be confused. Next question. Find the focal length of a lens of power minus 2.0 D. There is a lens is given whose focal length is not given, that we have to find out, but its power is given, that is minus 2.0 D diopters. Here negative symbol indicates what? Negative symbol indicates what? That already we discussed. We will see this one. What type of lens is this? Power of lens P equal to 1 by F. This is the formula. If you substitute, take the data here, power equal to minus 2 diopters, focal length equal to minus 1 by 2, 1 by minus 2, that is minus 0.5 meters. Focal length is minus 0.5 meters. A concave lens has a negative focal length. Remember, concave lens has a negative focal length, therefore it is a concave lens. Concave lens. General, the problem here is myopia. Myopia is the problem here. Okay, myopia is the problem. Negative symbol. With this negative indication, we can say which type of lens it is. If it is plus 2, it is convex lens, right? Because image is formed on the right side of the convex lens, that is positive. If image is formed left side, that is negative. Next question. A doctor has prescribed a corrective lens of power plus 1.5 D. Just now we discussed that if plus symbol is given, that is convex lens. Convex lens. Find the focal length of the lens. Is the prescribed lens diverging or converging? Now, my dear, you see, convex lens is converging lens. Concave lens is a diverging lens. We know that. Now, let's see the answer. Power of lens P is equal to 1 by F. A power is given 1.5D positive. Focal length equal to 1 by 1.5, that comes around 0.66 meters. That's a positive. That means convex lens. This person is suffering from hypermetropia. That means he can see the longer objects, but he can't see shorter objects. A convex lens has a positive focal length, therefore it is a convex lens or a converging lens. So my dear friend, my dear students, I think you have all understood this question and answers, and please practice number of times. If you have any doubt, any queries, please send a message to me. I will clarify all your doubts. Thank you. All the best for your exam.